We are A-Town Data, an Atlanta-based team of DevOps consultants. We build IT automation and monitoring solutions and upskill teams to use them effectively. Today, we'll be monitoring a highly available microservice that provides an API for IP geolocation. This is a custom solution built with Riemann, Elasticsearch, and Kibana. It provides a configurable dashboard with a global view of the system, the ability to implement custom alerts, a great tool to investigate issues or unexpected behavior, and information needed to predict future resource requirements. The GeoIP microservice provides an HTTP endpoint that accepts an IP address and returns the geolocation information associated with that IP. For example, let's get the info for this IP. Cool. It's returned the correct location of Atlanta. Okay, let's go ahead and take a look at the monitoring dashboard in Kibana. This is a real-time updating dashboard that monitors every node in the microservice deployment. The map in the top left is a real-time display of the locations returned by the microservice. We can hover over pins to see additional detail. Here we can see the number of calls to the API over time. This is helpful because we can observe relationships between the request load and the system behavior. Below, we see the CPU, memory, disk utilization, and load across all nodes in the microservice deployment. In each of these visualizations, we can filter and see utilization for individual nodes. Let's take a look at the CPU load of the proxy balancer to make sure it isn't acting as a bottleneck. If we expand the CPU utilization graph and look at the peaks, we see that the balancer has plenty of CPU headroom. Here, we can see that the memory and disk utilization is very static. This is expected since the service is simply loading a database into memory and returning values. If we were to see major fluctuations, we'd know something was wrong and would investigate further. To the right, we see the system load for each node. Since each node in the deployment has one CPU and the average system load is significantly less than 1, we can conclude that there aren't any processes that are having to wait too long to have the CPU become available. Thanks for watching. If you're interested in learning more about how real-time monitoring can help increase the reliability of deployments, please contact us at A-Town Data. Visit our site or send us an email at info@atowndata.com.